Okay, so this is a quick overview of the Breakout game skeleton code provided by the university for our first year project. Now, I know that a lot of other students have struggled looking through the code on this, and I'm not surprised why. I've had a look through all the slides that we've been through so far, and we're missing pretty much like half the stuff that's used here, if not like 80% of it. Other than the basic stuff like adding, I don't know, arrays to stuff and like doing simple bits like that. The meat of the code and how it all works is left a mystery to most people. So I thought I'd do my best here to clear things up a bit and try and give you more of a top-down overview of how all of this stuff links together. And also just a brief introduction to MVC because I don't think it was very well explained in the lectures. So yeah, just to break straight into it and not waste any time, let's start off with the main method here in the main class. So as you know, program starts here. Public static void main, string args takes arguments from the console, and we immediately run launch args. Now that's because we're running a JavaFX application. We're extending the application class, and that demands us to have a public void start method. And that is required by application, which is part of JavaFX. So simply put, launch args takes in some arguments, does some fancy stuff with it. We get spat out to start with the stage window, and this is where our actual code starts running from. So we assign a width and a height for the window, and then we move on to setting up the debug status. Now, I won't go into big detail on what's going on here. Simply put, we're going to be using multiple threads, and we're going to need to synchronize them together so that if we print from two different threads, that they don't clash. We don't grind the gearbox, as it were, between these two threads. They need to synchronize up and then work one after the other when needed to, so that way they don't have any bad interaction, right? And then there's this sort of standard style that it uses to print debug values to the console. So the style that it uses is it starts with the class name, 2 colons, and then the method name, 1 colon, and then the message. And I'm assuming the purpose of this is so that when problems arise, which no doubt they will, you can see what class, what method, and what it's doing, what message you want to give it, so that you can see how or where things have gone wrong. And you don't have to like hunt and fault find through your code. BlueJ doesn't make this easy. There's no way to check have a callback trace to find out where things went wrong easily, and it certainly doesn't allow you to find the call hierarchy of where these methods are run, where they originate from. So take that for what you will. BlueJ I'm not a big fan of, as you might have guessed right now. But it works, and that's what we're learning with, and I thought you guys are probably using it, so I'm going to stick with it for you guys. So moving swiftly on, we now have the mystic bit of model view and controller. So why do we have this here? The simple version is the model controls the state of the game. The view manages how we print the model to the screen, so the computer has values, not necessarily knowing how to print them out. The view translates the model into what we can see on the screen. And with just the model and the view, we can't control what's going on in our model. And it would just be sort of us looking through a window, unable to do anything. So the controller takes input from our view, which is our window. So when we hit keys on the keyboard, the view sends it to the controller. The controller updates the model, the current state of our game, based upon what we've pressed. And the view pulls that model to the screen again. So it has a nice little cyclical pattern to it. And that way our game runs through these 3 points we can see what's going on, we can control what's going on in the game, and the game responds to us in the view. So very, very nice little pattern there. And that's as simple as I can make it without going into too much detail or getting upset as to how they've coded this here. But simply put, we create a new model, a new view, and a new controller, and then link them all together so that they all have access to each other. So the model can update the view, the model has access to the controller can access the model, and the controller can access the view can access the model, and the view can access the controller. This seems a bit much considering what we're doing, but it works, and it's how they've set it up. I won't go into the details. Just know that everything has access to everything else if it needs to. Now for the fun bit. This is where all the fun begins. We tell the view to start with a window. And in the view, we have the start method, and it takes in a window. Now, the window that it takes in is the one that's provided by JavaFX up here. And this window is the main window that you start off with. And in view, it creates some stuff and essentially packs it all onto that window and shows it. Now, to give you a quick breakdown in a little more fine detail as to what's going on, we have a pane, right, which is like our main board that everything is glued to. We have a canvas, which is where the game is going to run within, right? So we're going to use the canvas to draw all of our objects that run in the game. And we're going to add that to the pane. So we're going to glue that onto the pane there. Same with the info text for the score. That is just a label that we also add to that pane as well. So now we've got two elements. We've got the canvas with our game, got the info text for our score. Now, in JavaFX, we've got these things called scenes, and essentially they allow you to switch between, almost like switching tabs. We can have multiple scenes with different objects on them. But for now, we've got one scene. We've got just this canvas, just this text. We have nothing else. We have one scene, and we'll add that pane to there. And now on here, we get the style sheet for breakout.css, and that just styles this label at the top here. It's not vital. If you remove this, then the text gets a little smaller. That's pretty much it. And then after that, we set what manages when a key is pressed on our view. And this is where our controller comes into play. Now, we haven't touched interfaces just yet. Just know that set on key press requires a method. And what this represents is it's saying in the view, we implement a handler. Like this view has a way of handling it. And the way of handling it, as we can see here, handle, tells the controller to run its user key interaction method with the event that comes in from handling that method, right? You could create a new handler within these brackets, but I think this is a nicer way of separating it out for now. I think that it would have been better to give us a nested method in here that we could just create a new object and then return the value up there. But that's something else completely. All you need to know for now is that this says that the view itself, view, has a way, here we go, up here. Public class view has a way of implementing a handler. It knows how to handle it. This handle method here is what it's talking about, and the controller manages what happens on the key press. And then this doesn't have to do anything just yet. We haven't even drawn the window, right? It's just saying when you do get a key press, talk to this handler as to what to do. And then it adds to the window our new scene with our pane, with our canvas, with our info text, and it shows it to the screen. Now, if I was to remove this model start game bit, we can see what it's doing right now. If we run JavaFX application, we can see our window that it's created under our view. You can see the score at the top here, which is our info text. The canvas, which looks very bland. There's nothing on there, so it looks like there's nothing at all in our window, to be honest. Just know that we can draw objects to this background here. And all of that lives within a pane, and that pane lives on a scene, and the whole scene lives on our window. So it all looks correct, and it's all following the right hierarchy. If you've ever done HTML, you know that you've got your HTML tags on the outside, and the body lives inside that, and then you've got like sections within that with divs within that. It's almost identical to that, right? You've got like a pane lives within a scene lives in a window, and the window shows it all, right? Very similar. If that helps you visualize how it works, then I hope that makes working this out a bit easier. But yeah, just know that just preps the window for viewing. No game code runs in there just yet, right? That is where the model start game method comes into play. So this model, as you know from up here, runs the start game method. And start game method is all the way at the top here. And it initializes the game. So it creates our objects and sets the score. And then it creates a new thread. Now a thread is, if you've ever heard of like multi-threaded processing and stuff like that, essentially you can run two things side by side. Instead of on a single line, you can split the tracks and have two different lines running next to each other. And all we're doing here is creating a new line, a new thread for our game to run on and to update the state of our game will run separate from the window that is accessible to us. So our window doesn't have to be, running at the same frame rate as the content moving within it. We can just have a static window with something in it running at a very fast frame rate. Now, we have not really covered much about threads yet, I don't think, from what I can remember. But all we need to know here, for now, is that it is creating a new thread, and in that thread, it will run a method. And it will run that method as a daemon, right? So this makes no sense to you right now, unless you know what it means, in which case, all well and good. But essentially that, as it says here, tells the system that this thread can die when it finishes. So at the end of this method, when it reaches the end of this method, this thread will gracefully close down. We don't need to manually shut it down. It will just gracefully finish. And we need to start the thread. It won't run until we tell it to start. Now, what it's telling it to start is this, which means this class. And it's the run game method down here. And this is where our main loop for the game runs. And it manages updating the current status of our game, updating how our screen looks when the changes are made, and then sleeping for a little bit so that each frame has a bit of buffer between when it runs and the next frame runs too. So that completes pretty much our main method. It will print as well that our game has started running because it has run start game. And we get stuck in this little loop until the game finishes. So we can see here, update game, references this one here. And as it says at the top here, this bit happens around 50 times a second and gives the impression of movement. All it's basically saying is every frame that our game runs, it's going to do this to animate, right? It's going to move the X and Y coordinate of the ball. And mind you, this is only the state. This isn't moving on the screen for us just yet. It's like updating the background, right? Oh, excuse me. I need more tea. So yeah, this is moving the ball's x and y coordinates, and because it's moving x and y, it's moving in like a diagonal movement, right? And then we get the ball's x and y top coordinate, which represents this little top corner here. And for some reason the ball's a square, and that's primarily due to how the view interprets the ball. The ball has a bounding box that is a square, right? And the coordinate it's referencing is the top left coordinate of it. Now, this check that it does here is basically checking if the top left corner is outside of the bounding box, right? Outside of the window's size. Now you may think, okay, well, can the ball like half or most of the way come out of the right? And it does a check for minusing the ball size and the border, right? So it can go out that far, but not quite that far because of the border, and also not that far because of the width of the ball, right? So on the outside walls for the right and the bottom, it will also check for the ball size, right? So it can compensate for that. Now, if you hit the bottom, there's a penalty. And you can see here in the code if it hits the bottom, whereby the y from here is greater than the height, so it's outside here, but not quite because of the border, as it says here, and not quite because of the ball size. So if it's just tap the bottom there, then change the direction so it goes back upwards next, and add to the score the hit bottom value. And the hit bottom value is negative because it's a penalty, and it adds a negative, which means it just basically negates 200 points from your current score, right? And yeah, it also does the check for on the left-hand side, or rather, oh no, sorry, to the top as well. So if y is less than 0, so if y goes like through the top, then change the y direction too. Now, the bit that we had to add for checking whether the ball has hit a visible brick is something that is better explained once we talk about how the bricks are generated. So if we go back up to that. The bricks are generated, in my version, through 4 different bricks built in an array, right? There's many ways to do this, and I thought this would be the simplest. Turns out there's an even more basic version that you can make, whereby you can assign bricks is equal to a new array of game objects, right? And let's say there's 4. And then for each of those 4, you can reference the array pointer from 0 all the way to 4. Right, so 0, 1, 2, and 3. And instead of putting them in these brackets, you could easily assign them up here, right? And the same for all these ones too. But this requires you to know the length, and it also means if you try to just gracefully add one more, you've got to increment this number, copy this whole line down, and increment this number here, which it's just a pain. So to save time, you can actually create a new instance of the game object array. Oops. Here we go. A new instance of a game object array, and in curly brackets after the square brackets, you can give it a list of objects separated by a comma. And all I've done is create 4 new objects, all separated by commas, with varying initial values for their constructors, like how they're set to start up. And very simply, every game object needs an x coordinate, a y coordinate, a width, a height, and a color. And all I've done is say first object starts at 0 on the x, and it has a brick width on the Y. So it starts a little ways down from the top. It has a width of 3 brick widths. So each brick width is, quite small actually. It's sort of like that big. So I just made it a little beefier, made it a little easier to hit. And 1 brick height, which basically gives it sort of that sort of size, right? If I can represent it through this window here. Yeah. And then we've got the color green for the first one, blue, orange, and yellow. And each time a new object is added, I've shifted the X position of where it starts up by the width of the previous one. So obviously the first one starts off at 0 and then adds 3 brick widths. I need the next one to start at 3 brick widths from the left. The next one's 6 because this one's got a width of 3 as well. 6 here and then 9 there. So you've got 1, 2, 3, 4, right? They've all got the same height. They've all got varying colors so you can differentiate them. And they've all got the same width. You may think this one's got 3 times the width. It's just because the first value starts off at 0. That would look a little more in line to make sure that you can see where the variances are. It's just in the X where it starts. Everything else is pretty much the same. Color could be the same too, but I just thought make it easier to see. Okay, so now we know how the objects are created. They live in this bricks array. When we go down here and check whether the ball has hit a visible brick, we loop through all the bricks, and essentially every time it runs this little loop, every brick here is set to the version that goes through here. So instead of going like int I is equal to 0, I is less than the total number of bricks, and on each time it runs increment I, so the first loop it'll be 0, second loop it'll be 1, third loop it'll be 2. Instead we can just say, okay, for every brick that belongs in bricks, do this to each brick, right? And that's what this brick here is. Every version that is in the bricks array, we do a check. If the brick is hit by the ball and it's visible, then we want to turn that brick off, set it invisible. So visible is false. Add the score because we've hit a valid brick, and then change the direction of the ball, right? Now, this doesn't handle if the ball hits the side of the brick, which can be something you can fix later. For now, all this does is check against each brick if it's hit by the ball. If it's hit by the ball, then turn it off, add the score, change the direction of the ball. And the same happens with the bat. If the ball is hit by the bat, the ball changes direction. So this pretty much mirrors. The only difference is that we're looping through all of the bricks. Okay? Now, there is a whole bunch more to this model class here. And we can see here model change. This is part of our main loop. And you may be thinking, what is this platform run later bit, right? What is this doing? And I had to look up the documentation for JavaFX because even I didn't know what it was doing. But to put it simply, platform run later essentially waits until the game is ready for it to perform an action, and it will spin up a new thread to perform the method that it's given. And the method we're given here is viewUpdate, and that belongs from view, and it manages the update method at the bottom here. And all update does is it gets from the model the balls, the bricks, the bat, and the score, and then draws the picture. Okay? And the picture simply takes the graphics content from the canvas, and like we said, the canvas is where it draws all of the game objects. It sets the background to white, sets the fill, so the size of the background, to start from 0, 0, and then span the full width and the full height. And then we're going to display the objects onto the game's canvas, the graphics content rather, the GC here, the ball, the bat, and for each visible object, each visible brick, and we're dubbing it OBJ, so each object in the bricks array, if the object is visible, print it, like display it to the screen. Now, this is done in the loop for main, up here. So under run game, we update the game state. We update the screen with how the model has changed. And if we didn't add a sleep in here, which just essentially says wait a little bit, like a really little bit, milliseconds, really, really short. If we didn't have this sleep, the frame rate would basically run at the speed of, I want to say, either your processor, how fast the thread is running, like the clock rate, which would be pretty damn quick, right? And by adding a little millisecond delay, we can just try and regulate it to about 50 or 60 frames per second. And we can vary it by asking, okay, is it in a fast state? Get fast essentially returns if it's fast or not, as a true or false. If it's true, then the delay is very short. Sets it to 10 milliseconds, very, very short, like very quick. And if it's not set to fast, then the delay is double, so 20. So it almost doubles our wait time and makes it run almost at half speed. So that is our main loop. We update the game, update the model, sleep on it. And our controller comes in from the view. So when we update the model, when we press a key, it updates our game state here. So when we run update game, it gets those new values already, and the model change will print those values. So it's a very graceful little loop here. It just updates the state, updates the view, waits a bit, does it again and again. Now, it can be very easy to get lost in all of this and think, okay, well, you've explained it so simply, right? It sounds, from how you've said it, very simple or very complicated. However you see it, adding and changing bits to this is going to be very difficult. So I'm going to try and give you a quick view on what you can do to change things, right? Now, like we said, the view manages how things are drawn to the screen, okay? Now, when we draw the ball or the bat, we could easily make another method here that doesn't just display a game object. We could display a ball. And instead of filling a rectangle, we could actually fill a sphere, some sort of circle. And you can easily Google this to find out how to do so. And all it would take is, instead of taking display game object, we could say display ball, and then make it draw a ball instead of a rectangle. And we could do the same for the bat and the bricks, but I think the ball is the most important here, because having a ball that looks like a ball does quite a lot for visuals, I will say. I didn't think it did until I did it, and it actually made a big difference. So that would be one easy point to update and change. Now the next would be adding more game objects. Now, using loops to loop through a list would be a lot quicker and a lot easier than having to manually work out each time, right? There's very consistent things that repeat here, such as the X position, right? The Y position will update on each row, right? So these are each column here. And if we had a new row, I'd have to copy all of these again and again for each row. So we could create a loop that loops through in I is equal to 0, I is less than 4, I plus plus, right? And that would give us our 4 in the columns here. And we can wrap all of that in a big loop that represents each row. So every row it will write every column which would write each one of these. So you go 1, 2, 3, 4, and that will complete our first loop. And then we go into our big loop around it, and it will go, okay, we'll do it again, but a little lower down. And it will do the same again. It will go, okay, yeah, I'll print 1, 2, 3, 4 with an increased Y. And then it will say, okay, do it again, but a little further down again. And you have an I and a J value, and it'll loop down. It'll look very graceful, and you can just specify how many rows, how many columns. And you can loop through the colors in its own array, if you so desire, right? For now, you could just make it a single color. And I will not judge you for doing so. I did that when I did the beginning bit for my own, so trust me, make it work, then make it pretty. I'm sure once you've got the main loop bit down, the looping through the colors will be a walk in the park, and it'll be a nice rewarding view at the end. So that would be quite a nice thing to do. Now, adding a slower mode here would be a pretty fun thing to do. Like in your game state, having a get fast and also a get slow. So you could increase the delay even more and make it super slow, right? And then change the fast to be really fast. Yes. Or even better, changing the speed of the refresh rate based upon how many bricks are left. Or just as time goes on, increasing this value, or decreasing it rather, to make the game slowly get quicker and quicker and quicker and quicker. And then eventually you're on the clock at that point, right? Because then the ball's going to be going everywhere, and it can get out of control very quick. Now, we know how many bricks are visible by looping through this array. Yeah, we need to do that to print them to the screen, right? We only print objects that are visible in this loop. You could do a check in your model, which checks, are all the game objects, all the bricks, invisible? And we could have some sort of end game state, which prints some sort of congratulations to the screen. You scored XYZ. And this would be a bit more involving, right? You could add that to this section here when it runs the game. If it equals finished, then we just simply print a debug here, which just says game finished. We could update the view here and then draw to the canvas a message, right? We could even add another invisible label in the middle of our screen that starts off with no text at all. And then when all the objects are invisible, we update the value of that. Similar to how we update the value of the score, right? When we draw a picture, we update the graphics content, but we also update the info text. We could just simply add another line, if end of game, print this text, yeah? And that way you could just have an end game state, something that looks a little more finished than just, oh, the game stopped. What happened? Did it crash? So just some food for thought on things that you could change. Just a brief overview of how the game works. I know I didn't get into the game object too much. This is sort of like every game object has a position, has a size, a color, and a direction that it travels, right, if it moves. So you have a vector position, you have a vector size, or rather an integer size, and you have a vector for like movement. And all this does is manage how the movement occurs and how it checks for if objects have collided. And this is something you could try updating to manage, okay, did it hit the top, left, bottom, or right? You know, because our model detects if it hits the left, right, bottom, or top of the screen. We could manage if it hits the side of a brick to, instead of deflect down, deflect up but in the other X direction rather than just the Y. Yeah, food for thought. I hope this helped someone. I know that I haven't gone into great detail. If anything's still not quite clear or you're having any trouble, definitely link it down below, right? Just send me a message. All the code here is available on GitHub. I'll leave a link for that in the description. I can't remember if I mentioned that or not. And that holds all the code working here. So if I run the game just before I go, you will get this, right? Which is a simple block ball that when it hits a block, it adds to your score. Very, very simple. Very, very sort of laggy. It works just as well as you would think. It manages how the ball collides. It manages how the points are added. There's no end game state, unfortunately. That wasn't within the minimum requirements that it requested. But it's a functional version of what we got given. So hope that helps. Have a mess about with the code. Don't be afraid to break something. And if you're unsure about anything, just let me know. I'll be making some more videos on things that I update to give you examples on how to add some extra functionality, and hopefully in doing so you can see how the game works in a little more detail. But this video is already stretched on long enough. Hopefully it helps you. I just pray that it does. Give it a like if it helped. If it didn't help, send me a message, leave a comment, and yeah. Happy coding. Have some fun with it. And don't sweat it. I'm sure you've got this.